Hello, ladies and gentlemen. Today we're going to be talking about how to graph absolute value functions or absolute value equations, which means we're finally expanding your knowledge beyond how to graph a line. So remember, this unit that we're in is all about graphing and writing equations of different functions. And so far we've talked about how to graph a line and how to write an equation of the graph of a line, which you already learned in previous algebra classes. But now we're finally going to move on to a different kind of function, which is an absolute value function pictured here. And the key idea is that it's going to be graphing a V all the time. So when you think of absolute value, value begins with V. That's the kind of shape that we're going to be drawing when we graph those absolute value functions. So what you're going to need today is a pen or a pencil and a calculator. And if you have the foldable, great. If you don't, you will have to write it directly into your notebook, okay? So when we talk about any kind of function here on out, what we're going to call each function or graph is the parent graph or the parent function, which means the original or simplest form of this function. So if we're going to graph a function of the absolute value means those double bars, right? So that when we plug in a negative number, the absolute value of that's going to come back positive. So the easiest graph that we can do is setting y equal to just the absolute value. And that's what we call the parent function. So if we would have a parent function of a line, the easiest slope is 1 with no intercept. So the parent function of a line is y is equal to x. So when we think of parent, we think of the original or simplest or easiest way to graph that kind of picture, okay? So the parent function or the parent graph for absolute value is simply y is equal to the absolute value of x. So when you go to graph, how you learned how to graph in general, way back in Algebra 1 was you just picked points for x and then you plugged them in to the function y is equal to the absolute value of x, and then we found what y was. So I'm going to pick some negative numbers, 0, and some positive numbers. Those are typically the numbers that we always want to pick when we're doing a parent function, just to see what happens on both sides of the graph, the negative side on the 0 and on the positive side, okay? So if I plug in -2 for x, so I plug in -2 where the x is, I'm going to solve y is equal to the absolute value of -2. Well, that's going to get me back to a +2. So that's going to be my y value for that appropriate x value. So what if I plug in -1 into the function? Well, the absolute value of -1 is going to bring back a positive number, which is just going to be 1. So that's my y value for that ordered pair. And then if I plug in the absolute value of 0, it's still going to be 0. So my ordered pair is 0, 0. And then if you take an absolute value of a positive number, like the absolute value of 1, you're still going to get back a positive number. And the same thing with the absolute value of 2. So those are going to be 1, 2. So then you're going to plot those points. So you have 0, 0, 1, 1, -1, 1, -2, 2, 2, 2. And then we could keep going, right? We know what's going to happen is it's going to be 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. And then it's going to be -3, 3, -4, 4, -5, 5, -6, 6, -7, 7, -8, 8, -9, 9, -10, 10. So we could keep plugging in multiple numbers to find that this is what it's going to look like. It's going to be a big V with the vertex or the minimum, that minimum value at the origin, 0, 0. And then it's going to go diagonally to the right, up 1 to the right one, and diagonally to the left, up 1 to the left one. So this is the parent function for the absolute value. So what happens then if I need to graph a function that doesn't look like just the parent graph? What happens if we have a number in front or a number inside that absolute value or a number outside the absolute value? How am I supposed to graph that if I only know how to graph the parent function? That is a great question. We are going to play around on Desmos and we're going to see what happens. So let's say I want to put a -3 on the outside of the absolute value. Look what happens. My whole entire graph moved down 3 values. So that's all that happened to the graph. What if I do the -3 on the inside of the absolute value? Well, that moved to the right 3. That vertex moved to the right 3. What if I do +3 then? Well, then it now moves to the left 3. So that function moves to the left 3. What if I put +3 on the outside of that absolute value? +3. Now I moved my graph up 3. Okay, what if I put the 3 out in front of that absolute value parent function? Look at what happened there. Here, I'll draw another one. Y is equal to the absolute value of x. What happened from that blue line to that red line is it's stretching it vertically, like if you were to pull the bottom, almost like a slingshot of that vertex, and if you were to pull it, it's stretching it to be tall and skinny. But what happens if we do something like 0.3? Now it's shrinking, we say shrinking, or it's widening that absolute value. So if I go back to my parent function, I'll do the parent function in red. So the parent function's in red, the 0.3 times x is in blue. And look at how much it's shrinking it down. Like if you were to take your hands on either side of the graph, up, bottom, and below it, on the top and bottom of the graph, and just press it together, it's compressing or shrinking that graph. Okay, what happens? Let's erase this one. What happens if I put a negative out in front? Now it's flipped the graph completely upside down so that it now has a maximum instead of a minimum. So what I'm trying to show you is that all of these things that are happening with a graph are called transformations. So it's moving the graph left and right, up and down. It's stretching, it's shrinking it, and it's even flipping it or reflecting it with that negative value. But how are we supposed to know or remember all those different transformations on the graph? So if we go back to our notes, I want you to write all of this down. I want you to write f of x is equal to -a times the absolute value of x minus h plus k. So what each one of these things is going to do, that negative value is going to reflect over the y, it's going to reflect the y value, or like we saw, it's going to flip it either to point down, opening down, or opening up. And then if there's a number, we call that number or that variable a. If there's a number out in front of the absolute value, it's going to stretch or shrink like we saw in the Desmos that I was showing you. So if there's a number, or like I had 3 and 0.3, if that number is going to be greater than 1, it's going to be a stretch. So it's going to pull it apart up and down. And then if it's between 0 and -1, then it's going to widen that graph so that it gets even wider. And it's going to change all of those y values when it does that, okay? And then the number on the inside, this minus h, that number is moving the x value, or it's moving it left and right? But remember, when we did it in the Desmos activity, it was opposite of what we would think. When we put in a +3, it moved left 3. And when we put in a -3, it moved right 3. So that's what that number is doing. Okay. And then k is moving the entire graph up and down. And because there's a plus sign out in front of this k, it's exactly what we would think it is. It's not opposite. So a +3 went up 3 and a -3 went down 3. So this is the generic form of transforming any absolute value function. So f of x is equal to -a times the absolute value of x minus h plus k. This is what we called translated form or transformation form of an absolute value function, okay? And so what I want to stress on this is that on the inside of the absolute value, what's going on with that h is going to change our x value in our parent table. And then the a and the k are going to change our y value in our parent table. And we'll look at some examples of what I mean by that. But make sure if you need to, you can pause the video and write all of this down. If there's one thing you need to write down today, it is this slide. This is the most important slide for you to write down today, okay? Okay, so let's look at some examples. If you need to take some time to draw the graph and the tables because you don't have the foldable, that's perfectly fine. You can pause the video at any point in time to draw everything out, okay? We only have 2 examples that we're going to go through today. So example number 2. We already did example number 1 with the parent function, so now we're doing example number 2. Okay, so we're graphing the equation y is equal to a negative, whenever there's a no number, remember it's assumed to be 1, a negative 1 times the absolute value of x minus 2 all plus 3. So before we go to graph it, now that we know what's going on with the transformations, let's describe them before we even talk about how my graph is going to change. So let's describe all the transformations that are happening to the function. The first thing we see is that negative 1 out in front, which means that it's going to reflect over the x-axis, right? Or it's going to open down, reflect over the x-axis. I spelled axis wrong here. Let me erase it. The x-axis, okay? That's the first thing that we notice. Then there's this minus 2 on the inside, which means that it's going to move the graph. Remember, it's the opposite, so it's going to move it right 2, not left 2. And then we have this outside number, plus 3, which is going to move the graph. It's going to move the graph up 3. So we know that this is in general what the graph should look like when we're done. We should have it move, the original V should be flipped upside down, so it's opening upside down below the x-axis, and then it's going to be moving to the right 2, and then it's going to be moving up 3. Okay, so let's draw a quick sketch of the graph by using the tables. So whenever it says draw a quick sketch of the graph, we're going to use tables to help us draw, okay? So from now on, because I don't know what numbers I should be plugging in to find what's going on with my function, because I could plug in -9 and -8, -7, -6, -5, and it might look like a line. So how we're going to go for the rest of the year is we're going to use that parent table that we created in the very first problem. We're going to use this table, and then we're going to do the transformations on this table to create a new table on how to graph it. So what do I mean? So let's first plug in -2, -1, 0, 1, 2. Those are always going to be my x values, and we're calling this the parent table. So remember, the parent table is using the parent function y is equal to just the absolute value of x, which means all these numbers are going to be positive, like we did on the very first slide. On the very first slide, 1, 0, 1, 2. So how you're going to start with each one of these graphs is you're going to use the parent table function. So you're going to plug in the same table. So it's always going to start with this table. Always, 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 okay? And then from there, we're going to do what we need to do from the transformations, okay? So what is happening to my x value? The only thing that's happening to my x value is always going to be on the inside of that absolute value symbol. So what's happening is I'm moving to the right, which means I'm going to be adding, remember it's the opposite, I'm going to be adding 2 to every single value if I'm going to the right 2. So I'm going to add 2 to every single value, okay? That's all that's happening with my x values. Then what's happening with my y values is I have a number getting multiplied by it, and then I have a number getting added to it. So I'm going to multiply by the -1, -1, -1 times a -1 times a -1. And then after I multiply, I'm going to add 3. Add 3, add 3, add 3, add 3. And then I'm going to write my new answers in the table that we actually want to graph below, okay? So a -2 plus 2 is going to be 0. A -1 plus 2 is going to be 1. 0 plus 2 is going to be 2. 1 plus 2 is going to be 3. 2 plus 2 is going to be 4. Okay, now I'm going to take 2 times a -1. So if you need your calculator so that you don't get lost in what's going on, so you're taking 2 times a -1, which is -2. -2 plus 3 is going to be 1. 1 times a -1 is -1, plus 3 is going to be 2. 0 times -1 is still 0. 0 plus 3 is 3. 1 times a -1 is going to be -1, plus 3 is going to get back to 2, and then -2 times a -1 plus 3 is still going to get me back to 1. So these are the points that we want to plot. So 0, 1, 1, 2, 2, 3, then 3, 2, 4, 1. And then we're going to connect the dots, draw the rest of the graph. And if we go back to our description, we said it's going to reflect over the x-axis, which it did. It's opening down now. That original vertex of my parent function moved to the right 2, and it moved up 3 to get to this vertex point, which the ordered pair, my last question they're asking me is, what is the ordered pair of that vertex? It's going to be 2, 3, which is always going to be the middle ordered pair in your table that we end with, okay? Okay, so that is how we are going to graph absolute value functions. We use the parent table, and then we use transformations to get us to the final table that we want to plot those ordered pairs from. Let's try one more example. Okay, so before we graph, let's describe everything that's happening with the transformation. So now I have this number out in front, and remember that number, let's go back. That number is less than 1, which means it's going to shrink my overall function by 1/2. So there's a shrink by 1/2 happening, or a compression, shrink by 1/2, which means that it's going to get wider, okay? And then we have a plus 3 happening in the inside, which means that I'm moving left 3, and then I'm going down 4. Okay, so let's do the parent table again. And the parent table is never going to change for absolute values, right? It's always -2, -1, 0, 1, 2, 2, 1, 0, 1, 2. Okay, so that's the same parent table as the last one. And then we're going to perform our transformations on that. Okay. Actually, I'm going to write my x values a little closer to the other side so I can perform the transformations on them. Sorry. It's the same thing. I'm just going to write them over here so I have more room. Okay, so now we are going to use the transformations that we described, and we're going to perform them on the parent table. So what is happening to the x value? The only thing that happens to the x value is what's on the inside of the absolute value, which is that plus 3, which is the opposite. We want a -3 because we're moving left. So it's the opposite. Okay. And then what we're going to do to the y's, we're going to multiply by 1/2. So we're multiplying by 1/2. We always multiply before we add or subtract. That's PEMDAS. Okay, and then we're subtracting 4. Subtract 4, subtract 4, subtract 4, subtract 4. Okay, so now let's simplify everything using PEMDAS and create our new table that we're going to graph. So a -2, I'll start with the x column. -2 minus 3 is going to be a -5. -1 minus 3 is a -4. 0 minus 3 is a -3. 1 minus 3 is a -2. And 2 minus 3 is a -1. If you need to use your calculator for this, that's perfectly fine. Okay, now we're going to do the y. So 2 times 1/2 is 1. 1 minus 4 is a -3. 1 times 1/2 is 1/2. 1/2 minus 4 as a decimal is -3.5. 0 times 1/2 is 0. 0 minus 4 is going to be a -4. And then look what always happens because our graph is symmetric. 1 times 1/2 is the same thing that I did up here. So it's going to be a -3.5 again. And then 2 times 1/2 is 2, minus 4 is, 2 times 1/2 is 1, minus 4 is a -3. I said that wrong. 2 times 1/2 is 1, minus 4 is a -3. And now these are the ones that we're going to plot onto our 10 by 10 graph. Okay, so -5, -1, 2, 3, -4, -3.5. So in between right there, -3, -4, and then -2, -3.5, -1, -3. Okay. So we moved from our original parent function. We went left 3, down 4, which is what we wanted with our description, right? And then we even shrunk it a little bit because it's getting compressed or pushed in from the top and bottom like that. Okay, so we did everything right. It matches our description that we originally had. And then the last question they're asking us is, what is that vertex? Remember, which is the middle ordered pair. So it's -3, -4 is our vertex right here. Okay, I know this was a little bit of a longer video, but the rest of your homework is a worksheet that's posted on Classroom. You can do the worksheet. If you have a printer, you can print it off yourself. If you got the worksheet from me, that's perfectly fine as well too. And then if you don't have a paper copy of the worksheet, you'll have to write it on loose leaf sheets of paper, all of the problems, and then graph to the best of your ability, and then take pictures and submit them on the assignment posted on Google Classroom. Okay, thank you all for taking such good notes, and I will see you soon.